Okay, this next unit here, our main focus is solving systems of equations and then later on applications of those systems of equations. So first in terminology, a system of equations is a collection of two or more equations in two or more variables. Okay, so anytime you have two equations in at least two variables, that's considered a system of equations. Now in this course we're going to be focusing on only the two equations in two variable case, and we're going to be interested in solving these systems, much like we solved linear equations or quadratic equations, and polynomial equations, fractional equations. Okay. To solve a system, and again we're focusing only on two equations, means to find all the ordered pairs x, y that satisfy both equations at the same time. So as an example, consider the system of equations x plus y equals 6 and x minus y equals 2. We'll just kind of label that as star. So what we're looking for are values that make both equations true. Okay, it has to make both of them true in order to be a solution. So for example, 1 for x and 5 for y would make the first equation true. 1 plus 5 is 6. But 1 minus 5 is not equal to 2, so 1, 5 is not a solution for the system. Now with one like this, it's pretty simple. You may be able to look at it and gather what the answer is. And that is that 4, 2 actually works. Put 4, 2 into the first equation, 4 plus 2 is 6. Put 4, 2 into the second equation, 4 minus 2 equals 2. So 4, 2 works. Now the question we ask though, so that makes it a solution, but then the question we ask is, does anything else work? Or is that the only answer? Could there be some other way that x and y, x plus y would be 6 and x minus y would be 2? Well, the answer turns out that there is not. Now to see why, we're going to look at our first way to solve a system of equations. It's also the most inefficient way and ineffective way to solve systems, but it gives us an understanding of what it is we're doing when we solve a system. So to see why, let's graph each of our two equations. So to graph, remember we need to plot points. So we need 2 points to graph the line. So here we could plug 0 in for x, solve for y, we get y equals 6. Plug 0 in for y, we could solve for x and get x equals 6. So 0 for x would give us y equals 6. 0 for y would give us x equals 6. Okay? And then we plot those points, and we can draw a line through them. Now that line represents every possible solution to the equation x plus y equals 6. So consider the second equation, x minus y equals 2. We could put 0 in for x. If we did that, we'd have negative y equals 2. And so y would be equal to negative 2. Okay, and then likewise, we could also find the y-intercept, or the x-intercept, by putting 0 in for y. We'd have x minus 0 equals 2, so x equals 2. We could then once again plot those points and draw the line that goes through them. Now that line represents all the solutions to x minus y equals 2. And so now we're looking for those points where both equations are true. Well, to make x plus y equals 6 true, you have to be on that line. To make x minus y equals 2 true, you have to be on that line. And so therefore we're looking for points that are on both lines. In other words, we're looking for that point of intersection. Now if you zoom in on that point, you should be able to see the x value is 4 and the y value is 2. That's our point 4, 2. And because these lines are straight, they're never going to be that close again. Right? They're going to go away from each other in both directions, so they will never cross another time. And so that point we found, 4, 2, from earlier, is in fact the only solution to this system. Now in the next video we're going to look at a second example of solving a system by graphing, and then we're going to talk about some of the ideas that we can get from graphing But graphing really actually is an ineffective method. It's a lot of work. For one thing, you have to be really careful graphing for another thing. And then the main problem with graphing is, what if our answers weren't nice whole numbers? What if we had fractional answers? And so that'll lead into our first, we're going to look at two other methods for solving systems that'll be able to pick up those problems when we have fractions and things like that. But in our next video, we're going to look at another example of systems by graphing, and then we're going to look at a little bit more that we can learn from the graphing aspect of solving systems. Till then.